So, I welcome you to this week 10 live session number 10. So, we'll just start after a couple of minutes. So, I think we should start. The attendance is quite low, but anyways, it's 5 p.m. We have to start. So, so this is week 10. So, this is live session number 10, where we'll be going to discuss problems related to week 10 material. And also, as attendance is low, you can anytime ask me questions or doubts whenever you feel you have any doubts. And to people, those who are watching live recordings on YouTube channel, they can always comment on the YouTube videos in case of any doubts, queries, or in case of any corrections and all. Please feel free to comment, and I'll try to respond as soon as possible. So today this is week 10. So let me just first share my screen. Just a second. Let me share my screen first. So yes, okay. So let's start. I will just give my introduction first, and then we can formally start. So, good afternoon, everyone. My name is Isa Rafiq. I'm the course TA for the course Digital Circuits that is taught by Professor Shantanu Chattopadhyay from IIT Kharagpur. This is live session number 10, where problems related to week 10 materials will be discussed. Problems will mostly be discussed based on VHDL, and also a couple of problems, a bit theoretical problems will be discussed pertaining to microprocessor. This is week 10. After this, two more sessions, live sessions will be conducted that will be related to week 11 and week 12. And week 11 and week 12 will mostly contain problems related to microprocessor and mostly on 8085. We will see them in coming lectures. Today, we'll mostly be discussing VHDL. So let me just check whether anyone else has joined. It's quite strange. Yeah? Anyways, so let's start with the first problem of today's live session. It's a theoretical one. So in this week's tutorial, there are mostly, what should I say, true, false, one line theoretical based problems. No concept involved. But what I have done is I have put programming questions, some of the programming questions, basic programming questions, and some of the syntax related questions of the AGL. I try to put them. And also we'll be discussing 20 to 21 questions, and most of them are theoretical. So the question one asks this: which of the following statement is true? Number one is SGLs are computer programming languages. SGLs and computer programming languages are similar. SGLs describe hardware rather than executing a program on a computer. Number C, option C, hard GLs describe software and not hardware. And option D, computer programming language describes the hardware. So if you people could have gone through your lectures, you can easily figure out the right answer. That is option B. This hardware description language describe hardware rather than executing a program on a computer. So what this HDL basically means, HDL stands for hardware description language. It is a specified computer language that is used to describe the structure and behavior of electronic circuits, and mostly these circuits are digital circuits. So among the following options, only option B was correct. Now, question number 2 of today's live session. It asks us, so someone wants to join. Let me just admit the person. So to the participant that joined late, so I discussed one question. This was, which of the following statement is true? SGL and computer languages are similar. SGL describes hardware rather than executing a program on a computer. SGL describes software and not hardware. Computer languages describe the hardware. So the correct option to this question was SGL describe hardware rather than executing a program on a computer. Now question number 2 of today's live session, it asks us, which of the following is the basic building block of a design? So the question asks us, which of the following is the basic building block of a design? Number 1, architecture. Number 2, entity. Number 3, process. And number 4, that is option B, package. So the correct option, if you are going through your lecture notes carefully, is option B, entity. So what basically this entity is, so we can imagine this entity as a black box which gives information about this inputs and outputs. So in VHDL, all the VHDL designs are implemented by entity. So we can, as I said, we can imagine this entity as a black box with input and output ports. So as you saw, this entity is a building block of this VHDL design. I have here a syntax of this entity. So this is a code snippet that shows the syntax of this entity. The entity syntax is triggered by this keyword entity that you see in this bold blue font entity, followed by the entity name. So this is my entity name. You can name anything. This is user defined. So this is entity name. This is your entity keyword, and then this is also your keyword, and port also. Then inside port, we define the port declarations. So inside this parenthesis, we define, just a second, someone wants to join. So we have discussing this question. Question number 2, which says that which of the following is a building block of a design? And as I already said, the entity is the basic building block of a design. So all the VHDL designs are implemented by entity. We can imagine this entity as a black box with input and output ports. So as this is a basic building block of this design, I have shown here a snippet of this entity's syntax. So this entity is triggered by this entity keyword, followed by the entity name, and then the keyword is and port. Inside port, that is inside the parentheses, are the port declarations. Inside port declarations are the port name. So this right here, in port 2 are your port names, followed by a colon, and then the port direction. So these are input ports. So how I figured it out, it's the input port by this keyword in, which refers to the input ports. And then we have this port type, that is a one bit. This std underscore logic basically is a data type which tells us this is a from the is a std data type from the IEEE package, which tells IEEE library, which tells us that this is a one bit data type. Also here similarly we have these output underscore port 1 and output underscore port 2 as your port names, And this right here out signifies that these are the output ports, and std underscore logic address, it's a 1-bit output. And then what we have, the entity declaration terminates with end keyword. So this here is your termination for the entity syntax, and followed by the entity name. This has to be similar to this name. So what we saw here is we are starting this by using the keyword entity, followed by my underscore entity, which is your entity name, then keyword is, and then port, followed by parenthesis. Inside parenthesis, we declare the ports, input, output ports, their directions and their types, and then we close them. And we terminate this entity by using this end terminate and keyword, followed by the entity name and semicolon. So this was just a very brief overview of this thing. What should I call this entity in a design? Now we'll move forward to this question number. What is this question number three? Yeah, we'll move forward to question number three of today's live session. It states that Intel 8086, that is 8086, is a dash processor, 8-bit, 16-bit, 32-bit, and a 64-bit. So this Intel 8086 is a, as you all know, is a 16-bit processor. So this number of bit processor means that data and register size of processor is 16 bits. And this number of bits basically refers to that number of bits that can be processed or manipulated at the same time by the processor. So Intel 8086 is a 16-bit processor. So data bus and registers are of size 16 bits, and that means the number of bits that can be processed and manipulated at a time by the processor. Now, I have this question. It states that which of the following is not an EDA tool? So the question asks which of the following is not an EDA tool? Option A, Verilog HDL. Option B, VHDL. Option C, Xilinx IC. And option D, Visual C++. Can you guys tell me which of the options is correct? So let me just read. Which of the following is not an EDA tool? Verilog HDL, VHDL, Xilinx ISC, or Visual C++? Anyone else? The correct answer to this question is option D. That is your Visual C++. Verilog HDL, you know, is a type of this HDL language, Verilog. VHDL you are quite familiar with, that is uh, VHDL. And then this Xilinx ISC, basically it's a dedicated software tool for Xilinx, from Xilinx, used for synthesis and analysis of HDL design. It's quite outdated right now. And this Visual C++, this is basically a compiler for C and C++ languages. People might have seen these FPGAs and all coming from this uh, Xilinx. So Xilinx is a company. Yeah, yeah, it should be D. So now question number which question we have discussed? Question number four, five. Okay. Question number five asks us, logic synthesis is the process of converting behavior level description to structure level netlist. Converting structure level netlist to behavior level description. C. Converting high level language to machine level language. Or option D. Converting behavior level description to architecture level. So the correct option to this question is option A, that is converting behavior level description to structure level netlist. In other words, you can say that converting an RTL to design in terms of logic gates by synchronous tool. So this was another theoretical question. So next question we have, which of the following is default type of ports of an entity? A variables, B constants, C signals, D functions. So question 6 asks us, which of the following is the default type of ports of an entity? A variables, B constants, C signals, D functions. So the default type of ports of an entity is signals. Since ports of an entity represent input and output of a circuit, the VHDL takes ports of an entity's signal by default. So this is one thing you can keep in mind. So the ports of this entity are in default are taken as signals, right? Whether it's an input signal or an output signal. So next we have this question. A microprocessor contains A ALU memory input output, B ALU control circuits and registers, C CPU memory input output, and option D CPU input output only. So can you tell me what should be the correct answer? Anyone else? You can also try this. Yeah, option B is the right answer. This was a pretty simple question. Option B is the right answer. So a microprocessor contains this arithmetic logic unit, a control circuits, and the register circuits. Now I have this code. So let's take a look at this. This is a snippet from this PHDL code. It shares a sum assignment A XOR B carry assignment A and B, where A and B are inputs represent. So what this code represents? Anyone? Other students also, if you please take part, it will be great. Actually, this week's session is mostly these simple one-line questions theoretical, but I try to include these, what should I say, these code snippets, the syntax related questions, VHDL related questions into the mix. Otherwise, if you can go by the standard questions that you usually have in this week, they are quite simple and usually one-liners and all. But I try to do an elaborated session, so it would be great if you can take part and also try to solve the questions with me simultaneously. So as one of the students has said, this code is a half header. That's why it's quite simple. So so basically what we have here is we have a snippet of a visual code, a code snippet, not the complete code, just a snippet of it. And we have this sum as A XOR B and carry as A and B. So we know, so it can't be full addition for it needs three inputs, multiply and divide also not. So we have this half adder. So what is the truth table of half adder? If you guys remember from your early lectures, this is A, this is B, this is sum, this is carries, and 1 0 1 1. This is right? So your sum is a XOR b, and your carry is a and b. So in terms of weights, you can draw it like this. This is your a, so b, your sum, and this is your and carry. So option A, half adder, was your correct answer. Now moving forward to question number 9 of today's live session. So I'd like you guys to tell me the answer first. So it says that in VHDL, assert statement is used for A, declaring flip-flops, B, reporting warnings and error messages during simulation of model, C, that is option 3, synthesis of VHDL code, and option 4, place and root of design. So in VHDL, assert statement is used for declaring the flip-flops, reporting warnings and error messages during simulation of model, C, synthesis of VHDL code, option D, that is 4, placing and root of design. So can you guys tell me what will be the correct answer to this question? Anyone? Any guesses? Or maybe any option that you are inclined to? What do you feel hazard segment does in? So at least you tried as compared to others and they are not taking part. Maybe they are busy somewhere. So what this hazard statement does, it prints messages at the simulation control when specified runtime conditions are not met. Basically, what I mean to say is they report warnings and error messages during the simulation of model. So what this assert statement does, it prints messages at the simulation console when the runtime conditions are not met. So there are basically four type of security levels defined by assert. So four levels are there. First is note. So note relays information to user about condition. So it relays information about condition. So relays information about the condition. Then second one we have, actually I have written it down, so let me just check. Second one is warning. Yes. So it's warning. It relays information about conditions that are not expected but are not filtered. So it relays information about conditions that are not expected and are not but are not failure. So relays information about conditions that are not expected but not fatal. Then we have error. So it relays information about condition that will cause model to work incorrectly. So that will cause model to work incorrectly. And last assertion we have is failure. So failure relays information about the condition that are catastrophic. So information about condition that are catastrophic. So in VHDL, alert statement is used for reporting warnings and error messages during simulation of model. Basically to print messages at the simulation control when specified runtime conditions are not met. So this is another question. So fill in the blanks type of basically just a second. Uh, Fill in the blanks type of question. So it states that how many actually I've shown the answer, but let me just tell you how many types of shift operators are there in VHDL. So let me just spell it out. How many type of shift operators are there in VHDL? So actually I tried to give this question to you only, but I think I have accidentally shown the answer. So the number of total number of shift operators that are there in VHDL are six. So in total there are six type of shift operators. Number one is rotate left logic, in short ROL. Number two is rotate right logic or ROR. Number three is shift left logic. Number four is shift right logic. Number four is shift arithmetic left. Number six is shift right arithmetic. That is SRA, SLA, SRL, SLL, SOL, ROL, and ROR. Total six types of shift operators are there in VHDL. Were you aware of this type of thing? There are six type of shift operators in VHDL. So I like to take a minute break and then we can resume the question number 11. So sorry about that. So now we can discuss question number 11. So question number 11 asks us a package in VHDL consists of A. Commonly used architectures, B. Commonly used tools, C. Commonly used data types and subroutines, D. Commonly used syntax and variables. So can anyone tell me what does a package in a VHDL consist of? A package in VHDL consists of you are given four options. So which of the options do you think is correct? Any guesses or any clue? So the correct option is option C, that it contains commonly used data types and subroutines. So what we do is we first have the library, then we from library we import these packages. So these packages are there so that programmers can use them in their design without defining the same function again and again. So they are once defined in the package and you can call them anytime you want. So if you have done programming before, you know that we have these functions in our programs which we define once, and whenever you want to use them, we call them. And also we have these libraries and all. Inside libraries, there are some already predefined functions. So you don't need to define them again and again. You just hit the keyword, you call them, and use them accordingly. Now, question number 12. In VHDL, bus is a type of A signal, C B constant, C variable, D driver. So in VHDL, bus is a type of signal which may have its drivers turned off. So in VHDL, bus is a type of signal, right? So now towards the question number 12 of today's live session. So before going to question number 12, what I have here is a complete code of an AND gate. So this AND gate, you guys are now familiar with this thing. So we have this AND gate. So two input AND gate A and B that are inputs to this and the output C. So the truth table is, and for this we have this VHDL code written here. So how we begin? What we do is we first introduce a library, that is write the first line, that is library IEEE. So we include this library IEEE, and from this library we import this package IEEE.std underscore logic 1164.al. So here we have this library. This represents library and IEEE. This is your package that we are using. And you can see these, I have some text that are written in bold. They are there because these are the keywords. As you saw earlier for the entity, this entity is a keyword. Now what we have here is this block represents your entity. So entity where your input output signals are defined, where directions are defined, where data types are defined. So how we do it for entity? We first write the keyword entity, right? So we write the word entity in TITY. And I think this VHDL is case sensitive, if I'm not mistaken. It's case sensitive. So please check that. I think I used it, but I don't remember right now. But I think it's case sensitive. Yeah, case sensitive means if I write some entity name in, let's say here it is written AND gate. A and D is in small, and when I close this entity, I write capital. So that means it will give error if it's case sensitive. If it was case insensitive, it would not give any error. So the case also matters. I think it's case sensitive. You guys can confirm that. So what I was saying that this there is the entity block. So we saw that entity is the basic building block of a design. So here entity, what I have written is entity, then I have written entity name. So this is my keyword for entity, then this is my entity name. This is anything, you can write anything. So here I have written this and then is keyword. After is we have this port. So port followed by parentheses. So port followed by parentheses will give declarations about the input output, their directions and their types. So I have my input A. So let me just add this as y for symmetry. So I have my input A. Then I have my input B. So how I say this is input by because I am writing here the keyword in and here also the keyword in. So this tells my code that this is the input port And this input port is of data type std underscore logic. So std underscore logic is a data type, and it's a 1-bit data basically. It's a 1-bit data. And also then I have my signal y, which is the output signal, and this is also a 1-bit data. So these are my inputs, and these are my outputs, right? And see right here, this entity AND gate is port followed by parenthesis, then A colon, the in std underscore logic followed by semicolon, B colon, then in underscore followed by std underscore logic semicolon, then Y colon, out space std underscore logic followed by parenthesis, then semicolon. And now all the ports have been declared, their directions have been declared. Now we need to close this, terminate this entity by using this keyword AND. So this AND tells me that we are terminating this entity, and then we write the entity name. So this has to be similar to this, and then followed by the semicolon. Next we have architecture. So in architecture we define the what process we are doing basically, what is basically happening. So we have this architecture. This is a keyword followed by the architecture name. So this can be any name, user defined. We can define anything. Then there is this keyword. Then here I have to write entity name. So this AND logic, this architecture AND logic is part of basically that entity, right? And then this keyword is. So architecture, then the architecture name, then of, then the entity it's part of, then is. Then I have the statement begin. So that means architecture starts. And then what I do here is I have this assignment this, statement here. Why this thing? So this thing means assignment. So I'm assigning y as a and b. So this and is here predefined, which is this operation. So I'm just telling that in y assign a and with b. So the result of a and with b get assigned to y. And then I have semicolon. So don't forget these colons. And then I have to end this architecture. So I write end again a keyword followed by the architecture name, that is and underscore logic. So this is and underscore logic, and then semicolon. So this was your a code syntax for an AND gate. So what we did here is we first introduced the library by writing library IEEE. Then we introduced the package std underscore logic 1064, all packages from this. And then we wrote the entity as entity gate, where we defined inside ports the inputs, that is a in underscore std underscore logic, b that is colon in std underscore logic, and then the output, which is the output logic. And then we close terminated this entity by writing the keyword end. Then we have the architecture and logic, which was part of the entity and gate, and then is begin, and then we assign the operation a and b to y, and then we close the architecture by adding e and d and logic. So this was the syntax for a and gate. Now what I'll have here is something just happened with my PC. Just a second. Okay, and now it's fine. Yeah. So now what I have here is I have another question. That is question number 13. So what I would like you guys to do is find the syntax mistakes. Go line by line and tell me whatever mistake there is in line one, whether there is any mistake, line two, or just point out the mistakes. So I explained in detail the what should I say, the syntax of an AND gate. So it's a like for like replacement here. You just need to remember the points I mentioned earlier and just find out the mistakes that I have written here. You need to find out the mistakes, syntax mistakes basically, mistakes in syntax that have been. So I'll give you 3 4 minutes. You can find these mistakes, and then I'll show you the solution. It's quite simple that. Begin in architecture is one of the mistakes. Other than that, can you find some other mistakes? There are some very minute mistakes. There are other mistakes also if we can find them. So you need to find syntax mistake in VHDL code for an OR gate. So basically we are trying to write VHDL code for an OR gate and you need to find out the mistakes. So let me just show the solution. So first of all, let's see whether statement line number one is correct. So library IEEE followed by the semicolon is correct. Then we are using the package IEEE.std underscore logic 1064.all, but this all needs to be terminated by a semicolon, right? Then I have entity or gate is, that's correct. Then port. Then I have a in underscore std logic, b in underscore logic, y out underscore logic, that's correct. Then I have and or gate. This here is colon. It should be semicolon. So this should be semicolon. So this was mistake number one. So mistake number two. Then I have architecture or underscore a of OR gate is. So architecture of is there, but begin is not there as you rightly pointed out earlier. So this is three. Then I am assigning y is equal to a and b. So but this needs to be or operation. So this has to be or b and semicolon and so here you need to end architecture, not the entity. So this has to be or underscore a. So this was four, this was five. So five mistakes were there in total. One and two were syntax mistake in terms of it was not ending by a semicolon. Then we had this mistake begin was missing, and also here I was writing a code syntax for OR gate, but in assignment I had written an AND gate, so this was mistake number four. And then I have AND in architecture, which needs to be ended with an architecture name. So architecture name was OR underscore A, but I had written OR 8, so that was mistake number five. So in total there were five mistakes. Yeah, you figured out, yeah. So this was the main idea regarding this PHDL code. Now, I have this question. It states that which of the following is correctly declared library for VHDL code? So, library name, use, package name, dot parts, library use, library use. So, you guys saw some of the snippets. Can you just tell me which one is the correctly declared library for VHDL code? Yes, option D is correct. So option D is correct. So library name and then the package. So basically, library declaration is done in two lines. So what I need to say is library declaration is done in two lines. In line first, the library is declared library, that is IEEE here in our previous case, and in second, use clause is defined to define the package name we want to use from respective library. So a use clause is being there to define the package name we want to use from respective library and the parts we want to use. So here the parts we want to use. So in previous code we had this library IEEE, right? This was your library, and we were using the package IEEE.std underscore logic 1164, and all means all parts of the sections in package are used. So all parts are used. This was your package. So in two lines, we have this first the library is declared, then use clause is used to determine the package and the parts that are you are going to use. So option B is the correct answer. Screen not clear. Maybe some connectivity issues. So let me just check. Is it is it clear now? The text in the question. Okay, okay, yeah. Okay, okay, that's fine. So we have another question here. So I guess you'll be able to read this now. So it asks us, what does VHDL stand for? Option A, very high speed, high special integrated circuits hardware description language. Option B, very hard description language. Option C, very high speed integrated circuits hardware description language. And option D, Verilog HDL. So uh, as you have written, this VHDL basically stands for very high speed integrated, a very high speed integrated circuits hardware description language. So this is your V and this is your HDL. So VHDL. Then I have this question. Let me just increase the font size. So this question asks us, which of the following is the correct VHDL entity declaration for the block diagram given below? So you need to tell me which of the following is correct VHDL entity declaration for the block diagram given. So the block diagram is given A, B, D, U, T, P, Q, R, and you need to figure out which is the correctly declared entity. Anyone else? The other participant, can you tell me which of the following is the correct VHDL declaration of the block diagram given below? So, so in entity, as I told you, what we do is we define the inputs. So as per the diagram, A and B are my inputs, and P, Q, R are my outputs. So my entity should be somewhat like this. So A has to be in, B has to be in, P, Q, R has to be out, out, and out. So entity port duty is port A in bit, B in bit, P in bit, Q. So it's also showing P as in bit. So this is incorrect. Then A in bit, B in bit, P in bit. So this is also incorrect. Then A output incorrect. So A in bit, B in bit, P output, C Q output, R output, and then I'm ending the duty. So option C is the correct answer. Now question number 17. Which of the following is not an application of VHDL? Anyone? Which of the following is not an application of VHDL? So as you rightly said, option D is the correct answer. That is modeling of analog systems. So this basically VHDL is mainly used to is used to model the model instances of digital systems. Now option question number 18. Which of the following is not defined by an entity? A. Direction of any signal. B. Names of signals. C. Declaration of ports. D. Behavior of the signal. Yes, so option D is correct answer. So as we saw, entity describes the direction, name, and declaration of the signal. So option D is not defined by the entity. Then I have question number 19. Which of the following statement is true? Microprocessor contains memory to store program and data. Microcontroller does not have an on-chip memory. Microcontroller contains memory to store program and data. Microprocessor contains memory to save store program. So which of the following statement is true? So the correct answer to this option is option C. Microcontroller contains memory to store program and data. Then I have this question which I would like you to do first. See, today the audience is quite low. Anyways, so just identify the basic. Yeah, I hope it's visible now, right? Is it visible or should I increase the size? Okay, so identify the basic logic described by the following VHDL code. So we have circuit process ABC. So process means any change in the between A, B, and C, the statement will be start executing in a sequential manner. Then I have begin if S equal to 1, then Z is assigned as A, else Z is assigned as B, then I am ending the if condition and end process. So can you tell me what this circuit does? So as you rightly pointed out, so this circuit is a 2 is to 1 mux. So what we have here is we have circuit underscore S and then process. So any change between these three, this thing will start executing in a sequential manner. Then I have begin S equal to 1. So when S is equal to 1, so basically a 2 is to 1 mux is written by a select line two inputs A, B, and then Z. So if S is equal to 0, B, this is 0, 1, this gets to the output. If S is equal to 1, this gets to the output. So begin if. So it says if S is equal to 1, then output Z gets assigned as A, else it gets assigned B. So there are two cases only, S equal to 1 and S equal to 0. In S, Z gets assigned as A. In 0, it gets assigned as B. So this is simply a working of what should I say, a 2 is to 1 mux. So where it is written as y is equal to s bar I0 plus s I1. So this is simply this, and this is a 2 is to 1 multiplexer. That's a simple thing. Then VHDL and Verilog are software description language, assembly language, hardware description language, and machine learning language. The name itself tells us it is a hardware description language. Option C. Now, these were all the questions that we had to discuss for today's live session, but I have kept two more, just a second, two more, what should I say, snippets, not snippets, complete codes of a 4 is to 1 multiplexer and a D flip-flop. So, I would like to show you to them. Actually, this week's live session and this week's problems, they are quite, what should I say, theoretical, very theory driven, and since this core is pretty, what should I say, uh, should I call it UG level? Yeah, it's pretty UG level, and that too early UG level. So it's quite basic. But once you enter the high level courses, you'll get familiar with other stuff, and mostly you'll do coding related exercises, and your assignments will be mostly related to coding. So just to keep it simple and all, and keeping in mind the syllabus, I have here two snippets, two codes, in fact, VHDL code of 4 is to 1 mux and a D flip-flop. So I'd like to discuss that thing with you in detail. So here, what I have here is a 4x1 VHDL code. This right here was just the snippet of a code. It was not a complete code, just a snippet. So sometimes in theoretical exam, you will be asked to write the snippet, the algorithm and all. But here, I have a complete 4x1 mux VHDL code. So what I have here is, I will go line by line. So this library IEEE, we all saw that this is the library we are using, the IEEE, and then we are using the packages from this IEEE library. And I'll not go into the details of these packages. You can refer to the lecture notes or you can Google them. What are these packages? But these are simply the packages that we are using, right? This library and the packages that are used by the keyword use. Then we have the basic building block of design as we saw in the question, that is your entity, right? So entity is the keyword, right? So I have written entity. Then this is your dpun is your dpun underscore mux underscore out is your, or should I say, your entity name. Entity name. And then I have my keyword is, this is a keyword KW. And then the port followed by parentheses. So inside parentheses, what we'll have inputs, the outputs, and the data types. So I have input name as input one. So basically 4 is to 1 mux is something like this: 1, 2, 3, 4. This is 1, 2, 3, 4. Two select lines S1, S0, and one output Y. So I have input one, that is input. This is here defines the input, and then under std underscore logic, which means that it's a 1 bit data. And this right here, you might be seeing this for the first time. This is basically comment. So we have this portion that is written in the code, but it will not be executed. This is simply as a programmer's exercise. Whenever we write any codes, we tend to write a statement, basically what this part of the code does or what this part of the code stands for. So whenever you are doing coding, make it a habit. Always write comments. For different languages, you have different syntax of writing comments. So always write as comment at the end of your line. So this right here, by using two dashes, simplifies the comment. So this part will not be executed with code as if it's a nothing is there. When a compilation is done, you will see anything. You will see a part, omit this part. So mux, so it means this is a mux input one. Then I have I in two, then colon in std underscore logic, that is input two, one bit in I in three, that is another input, I in four, that is another input, std underscore logic mux input four. Then I have select, uh, that is again SEL, that is again input, and then I have std underscore logic underscore vector. So this means that is a array std underscore logic underscore vector 1 down to 0. So it means that it is a 2-bit, it is a, what would I say? It is a array consisting of two values, and 1 down to 0 means that the first bit, that is this one, is your MSB, and this is your LSB. So it is an array consisting of two values. This is your MSB, and this is your LSB. So how we figure out this is my MSB and this is my LSB? By using these keywords 1 down to 0. And then they have semicolon, and then it's a comment selection line, and then they have data out, which is the output std underscore logic output data. Then I am ending my entity by using the keyword end, and then I have this deepen underscore mux underscore out, which is my entity name, similar to this one. After that, we need to define the architecture, so we'll use the keyword architecture. So this is architecture. So this is the architecture name, architecture name. This is of a keyword. This is deepen underscore mux underscore out. This is the entity name. Then the keyword is, and then I have begin, and then I have the comment this process for mux logic. So here we are seeing this process, which we saw here also, this process. So this process is basically a part of code that is executed sequentially. It consists of the parameters inside this parenthesis. Basically, it is a part to which the process is sensitive to. Basically, we are seeing these inputs, select input 1, input 3. Basically, whatever changes will happen to any of them, the part of the code below it will get executed sequentially. So this process is a code that is executed sequentially. It consists of the sensitivity list, the declarative part, and the SQL selection. That is the sequential selection that is to be followed. It's quite so. Then what I hear is, uh, then I have begin. So this thing begin. Then I have case select. So basically, this select, that is the vector, will be input vector that will be evaluated. So we have this case statement executing on the select, then followed by key is one. Sorry is. Then when this select is 0 0, assign my data output will get assigned input 1. When select is 0 1, data output will get assigned as input 2. When select is 1 0, data output will get assigned input 3, and when it's 1 1, data output gets assigned as input 4. And when it's other condition, then data output gets assigned 0. Then it's the end case, so this case needs to be terminated by this end statement, and then it's the end process. And finally, we are ending the architecture by end and the architecture name. What we have done here is simply when s1 s0 0 0 0 1 1 0 1 1, y is equal to I1, y is equal to I have written 1 2 3 4, so I1, I2, I3, and I4. So this thing input 1, input 2, input 3, input 4, this is basically happening here uh, inside the process list whenever any changes will occur to any of the signals. So this was a VHDL code for this thing, what should I say, for a 4:1 mux. Then I have also a VHDL code for a D flip flop. So what we have here is, first we have this library IEEE, as you saw earlier, then the packages we are using, and then I'm defining the entity by keyword entity, then the entity name. So dff1 is entity name, then the keyword is, then port followed by parentheses. So earlier you saw these input 1, input 2, they were defined in separate line, but also you can define multiple inputs in a single line separated by commas, then followed by a colon and in underscore std logic. So D reset clock, so DRES clock colon, they are all inputs. So this statement tells the thing is all inputs by in keyword and they are one bit input by this std underscore logic. Then I have Q as my output, std underscore logic again, and then end DFF1. So this is the end keyword, and this is your entity name. Then I have architecture. So this is the keyword. Then behavior is the architecture name. In short, I'll say AM. Off is another keyword. DFF1 is the entity name, and then is so begin. So process. So basically, our D flip flop is something like this. So this is D. This is your clock, and this is Q. So D is equal to Q. Or should I write Q is equal to D? That's better way of writing. Q is equal to D. So process clock. So again, we have this process. It executes the code sequentially when there is a whenever there is a change in clock. So whenever there is a change in clock, this thing will start. So then we have this keyword begin, begin, and if reset equal to one. So if reset is equal to one, then assign Q, then assign zero to Q. So it means whenever reset is high, my output will be zero. Now this statement is interesting. It states that else if clock event. So clock event means clock and apostrophe event means whenever there is a change in clock, any change in the clock event, and clock equal to one. So can you tell me what this statement actually does? Clock apostrophe event and clock equal to one. So what this actually means? Yeah, correct. So it is a basically it tells us that it is a positive edge trigger clock, right? Positive edge triggering is happening. Since our device flip flop can be positive edge triggered or negative edge triggered, so here they are taking a positive edge triggered clock. So clock underscore event means a clock is changing. It can go from 0 to 1 or 1 to 0. But then it's saying and clock is equal to 1. That means a positive edge. So clock was 0 and now the clock is 1. This thing change and the clock is 1. So this means a positive edge. So when there is a positive edge, assign D to Q. Then end the if condition, then end the process, and then end the architecture. So this is the architecture name. So in this way, we have a D flip-flop VHDL code. Any doubts in this? Event basically means what events do. I mean to say, yeah, event scheduling basically means any change that is happening in the clock. Clock underscore event. It is the syntax for that. Whether it was, let's say it was a zero, now it goes to one. So this thing means there is a change and this will be one. So like we had in process, we write process and we write clock. So in process clock means whenever there is a change in clock, just execute the code below. Similarly, clock underscore event means any event change that has occurred in clock. No, it's I think it's a general syntax which you can write. I think I'm not sure, but it should be going by the logic. It should be a general way of writing. Yeah, yeah, yeah. Because clock, huh? Because clock here is a signal, right? Yeah, because no signals. Yeah, yeah, obviously signals. Yeah, because our as you saw in one of the theoretical question that the default data type that you get assigned to an entity is signal itself, right? Any other doubts in the earlier questions, Zohan? So this was related to what should I say VHDL code mostly, and I tried to give an idea about these D flip flops and mux and all using these VHDL codes because what we have studied in past in previous lectures, we studied these combinational circuits, the sequential circuits. Now their implementation in VHDL, I thought I can give a flavor of that. In multiple choice questions, you don't get the exact details of that, so that's why I included them. And also the multiple choice questions of today's live session, they're quite simple and straightforward. That's why I thought I will give a theoretical bit of this, and you can also frame questions out of this. So right, you can people can ask you questions and give you the snippet, begin process clock, what this does. So multiple questions can be extracted at a, UG level from these type of questions. So it's quite good if you have a knowledge about them, and it will also surely help you in the future. And this was for all for today's live session. Next week live session, we are going to discuss what should I say, microprocessors, questions related to microprocessors. And in fact, the last session, that is session number 12, we will also be discussing microprocessors. So now two sessions are remaining. I think I should wait for at least 5 minutes. Maybe someone might join, and then we can close the session. You guys can remain. It's your wish. Otherwise, nothing new will be discussed. Only this portion is discussed. Thank you for joining. So, Mugesh, you were there for the whole time, but you didn't answer any question or take part. I can see your message, Mugesh. I can see your message now. It wasn't well. It was not working earlier, right? For you? Okay. Were you able to understand the questions that we discussed, the syntaxes that we discussed, the VHDL codes we discussed? Any doubts? Any queries? Okay, thanks for joining. I think it's your wish. If you want to be in this session, I'm just waiting for a couple of minutes to see if anyone joins. I guess no one will join. Otherwise they would have joined earlier. But it's your wish. You can remain in the meeting, or if you have any question in general, you can ask. This can be a maybe a pep talk you like to have, or any query you want other than your this course or any other thing you want to ask, you can have. But other than that, if no one joins for 2 3 minutes, we can close the session. So you can ask anything. So you are a bachelor student, right? Okay, so Mukesh left. So people that are watching live recording, so any queries, any questions, you can ask in the comments. And actually, it's quite a blessing for you guys that you are having three TAs, and with that, you'll get a different flavor from different TAs. And also, try to refer books and all. Sometimes we might not cover because we are limited by the time, the syllabus, and all. We cannot cover every uh, point. You guys may refer to the syllabus, see your textbooks, reference books. And also any general comments you would like to give regarding the way I'm handling this course, any general feedback. Actually, I try to cover almost every question because last year I was also teaching this, not teaching this, doing this live sessions. So this year I try to be more in detail and all. I'll just wait for a couple of minutes and then we can close the session. So thank you guys for joining. So in case of any doubts, queries, please yeah, comment on the recording on the YouTube channel. Thank you. See you next time. Thank you guys.